This week on Let's Make It, we're going to take a 1-week detour from the Arduino and look at a Raspberry Pi. Up next. It's time for another episode of Let's Make It. This is episode 16, and this week we're going to do something just a little bit different. I know last week I mentioned we were going to do shift registers, and we're not going to do that this week. We're going to put it to next week, and that's because I didn't get some of the hardware until real late last week, and the weekend being such a nice weekend as it was, I did a lot of yard work and didn't have time to experiment with anything. So, but I do have a lot of the hardware here. Here is a shift register. So you see it's just a little chip. We're going to, next week, demonstrate what a shift register does. So I do have all that hardware now, and as part of the demonstration, I also got a couple more things here. Let me take it on the bag and make it a little easier to see what they are that we're going to use in this demonstration on some ways you can use shift registers and save some pins. So let me go to the overhead camera before. So I have these little LED arrays. I have this one. I have one that's square like that. It's basically the same size basically. And then I have a smaller one here somewhere. There's a little one. You can see just a little smaller. It basically looks the same number of LEDs and everything. And then, oops, that's good. The other thing I got was a 7-digit display, and this one's a lot bigger. Sorry for all the noise, but I just should have taken them out before I did the show. So you can see this, which is a lot bigger. This is really big numbers, and maybe we'll try to make a clock or something out of it. You know, I don't know if I showed anybody in this show yet, but I've custom built some recording clocks. So when we hit record on the recorder, we can kind of tell how long the show is. And how long we've been talking and stuff like that. So, but maybe we'll take something like this, which is even bigger, the ones I got. This is here's much bigger actually, and we'll do something with that. So, you know, the whole idea of the shift register is to help save some pins. So if you think about it, like if you look at one of these, and if you did the traditional wiring where you have like a minus or a common, and then you have a positive one from every pin for each one of the LEDs, you very quickly run out of pins on the Arduino, so we can use a shift register to get around that. The other thing that I picked up was, is this it? No, it's a shift register. Let's see, what's this? That's a shift register somewhere here. Oh, here it is. This is a display driver. So it's designed to drive the 7-segment displays. And we'll look how these work as well. They work on a very similar principle to what a shift register does. It does a lot of the work for you just by sending it certain codes, kind of like what a shift register does as far as multiplexing pins. So let me grab the one that dropped here. Yeah, I dropped this little thing. That's what the noise was. All right, so this week what we're going to do, and as you can see by what's sitting here, we are going to do some Raspberry Pi. And we've talked about Raspberry Pi and wanting to do it, and we've had a lot of people ask us about that. So I finally decided to go ahead and do a show on Raspberry Pi because I wasn't quite ready to do the shift registers. I wouldn't have been doing a quality show from just rushing through it. But I've been playing with these Raspberry Pis, and actually been playing with them a lot more here recently, even more than the Arduino. And I can give you a couple of reasons why, but what we're going to walk through tonight is going to show you the board again. And we did this in our first or second episode. And then I'm going to show you how to load code onto the card and where to get it from. And then I'm going to show you a program that I wrote in Python that simulates what we did in episode 10. And so you'll go back and look. Episode 10, we did a read from the internet from Ustream to see if our stream was up or down, and we turn a light on or off. And I talked about building an on-air light. And I'm still doing that. I have everything for the on-air light now, but I'm going to use one of these instead. And I'm going to show you the program, the Python program. This is very crude still. I'm still working on it, but you'll get the idea of how you can do the same thing with one of these. And I'm going to talk about through this process as to why this is better as well. So first thing I want to do is let's go look at this a little closer, and we'll talk about the board a little bit. If I can get the switch, there we go. So this is a Raspberry Pi, and no, it doesn't taste good to eat. But this is a computer that can actually run Linux, or actually I've seen it run a couple other versions of Unix now, even though they're still based on Linux. They're all Linux-based operating systems, but they don't call themselves Linux. And I will tell you, I've even seen somebody running Android on one of these. So an Android runs on top of Linux. Linux is the base for Android as well. So it's still all Unix-based base operating systems. But this card comes with, on the side, you see right here, is an HDMI. So you see no monitor plug, but you see HDMI. Most monitors today can take HDMI. And if they don't, you can get really inexpensive plugs at like Best Buy or Radio Shack that convert HDMI to VGA or to HDMI. On this side, you have an audio port, and then you have a standard video output port. Now, I've never tried to see what this looks like, but I wouldn't think the quality would be as good as the HDMI for using this as a graphic computer. This can do graphics. In fact, that's one of the projects I'm going to talk about tonight of how I'm going to use it. And then on this end, we have a plug. It's a USB plug. It is only for providing power. That is the only thing that it does. It does not provide any kind of data connection to this. In fact, that's how you'll see the one down here that's on is being powered via a USB plug. So that's all that little plug does. You can't program this with that. And if you turn this backwards, you see the little plug right there, and it takes SDHC cards, which I have one right here. Well, I shouldn't. It didn't have looking ejecting it, but basically it goes in just like this. And that simulates your hard drive. So this is a 4 GB. It's really small, but it's going to demonstrate tonight, what I need to do to install stuff on one of these boards. So the other one that's sitting here is running a 16, and I could either run a 32 or 64 depending on how much space that I need. So you just basically buy the card size that you need. So I'm going to take this out. I'm going to use it later. So on the other end, which we haven't gotten to yet, there is Ethernet. And there's 2 USB ports. Now, these are for a keyboard and a mouse or any other thing you want to connect to it. This does not have to have a keyboard or mouse to work. In fact, the one I have sitting here has no keyboard or mouse attached to. Actually, that's not true. I do have a keyboard adapter in there. I had it in there earlier because having some problems getting it to get an IP address, which is something stupid I was doing, not necessarily it. And I plugged the keyboard adapter in. You can see it down here is the keyboard mouse adapter, but I'm not going to use it for tonight's demonstration. I can just easily unplug it. In fact, I might do that just to not confuse anybody. So you see 2 USB and Ethernet. Now, what I have also done, and I showed this to you a week or 2 ago, I've gotten the Wi-Fi adapters that are USB and they plug right here in this end. And I have gotten one of those to work, and it's not as straightforward as I would have liked, but it does work after you get it set up. So I need to streamline that process for the idea of the on-air light, because I want to use wireless. I want to be able to plug it in anywhere and set it there, and it'd be able to go out to the internet via Wi-Fi. So I'm trying to figure out all that setup process. So that is pretty much it for this. Now, there's one thing we didn't talk about, and we're going to use tonight. You see this plug right here? This is called a GPIO. And on there, there's 5 volts, there's 3 volts, there's ground, and then there's pins, the GPIO pins. And GPIO basically stands for generic I/O interface. I don't know what the P stands for. Generic PC, I can't remember what it stands for. Anyways, it basically is very similar to the pins that are on the Arduino, where you can turn them off or on. These are like extra pins. So it's just generic input and output. And using certain libraries on this Raspberry Pi, you can turn them off and on, so we can on the Arduino. And that's what I'm going to demonstrate in the Python script. There's lots and lots of Python stuff for this. And Python, if you've never used it, it's a scripting, it's an interactive scripting language, but it's a little bit different than most languages. It's in some ways more powerful, in some ways a little bit more confusing. But after you learn it, it's fairly easy. You can pretty much exchange it with almost any other language. They just do structure slightly different. But there's plenty of libraries out there, and there's libraries for all kinds of stuff. And that's why I did Python, is because I thought about doing PHP, and the problem with doing PHP would be that there is no easy way to control the GPIO. So I would have had to, at some point gone into something that controlled GPIO, whether it be, I think you can do it in Perl, you can do it in C, obviously, but I would have had to go into some language that actually would allow me to control the GPIO. So I decided to stick with Python because I could put it all in one program. Python has the ability to read from the internet. It has the ability to read JSON or XML, either one, pretty easily with just popping in libraries. So the program actually is very simple when you look at it. It's not really well documented yet, and there's a couple of things I need to do to clean it up. And like, for example, if you unplug the Ethernet port while it's checking, it'll crash out of it, things like that. So now, the thing about this being Unix, here's one of the advantages to it. It being Unix, it can do more than one thing at one time. So with the Arduino, you write a program, and it's designed to do just one thing, and that's all it does. With this one, I'm going to log into the one that's running here, and I'm going to show you, there are tons of things running. In fact, it has a web server running one right now, because my ultimate goal, which I'll talk about here in a couple minutes with this light, is to do more than just the light. But because it can do more than one thing, and it uses like off-the-shelf software, like MRTG, I have an MRTG running on that one, stuff like that. So it's much more flexible, and I think that's kind of why I'm gravitating towards it a little bit more here recently, especially now that I figured out the GPIO. After I finally figured that out, it's a very powerful thing to do. So that is the Raspberry Pi. Now, what I want to do first is I want to show you how to get onto this, the Raspberry Pi operating system. Now, it's free, and there's different variations of it out there. I'm going to show you Raspian, which is the one. It comes from the Raspberry Pi folks. I have other variations of this. In fact, one of the things I'm going to talk about a little later is how I'm going to use it in the studio room as well. And I have a little bit different distribution that came pre-done, which was really easy to do. Actually, it was super easy. I was a little concerned, and I never had done it before. So first thing I want to do is I want to go over to my computer. I'm going to show you where to go, and this will all be in the show notes as well, so don't have to worry about writing it down. It'll be up online. I'm going to show you where to go and how to install this. Now, I'm on a Mac, and it's just as easy to do on a PC. I've done it on a PC before because I couldn't find the Mac software, but now that it's a little matured a little bit, there's a lot more information about the Mac software, and it's very easy to use as well. So I do have on my computer a reader for this kind of card, so I'm going to go ahead and stick it in the side over here. And it takes it a couple seconds to mount, so I'm going to go ahead and do that. And let me switch over to the computer. And let me get up here to the download. So what you do is you go to raspberrypi.org. You see right here, it's Raspberry Pi, and Pi is P-I, not P-I-E. If you go Raspberry P-I-E, you're going to find food. And so if you're hungry, that's where to go, but if you want to look for stuff for the Raspberry Pi board, that's the wrong place to be. So when you get here, let me just go to the beginning so you can see how it looks like when you get here. So it'll look kind of familiar to you. You're going to see a little blog right over here, latest information and stuff like that. So what you want to go to is the download section right here. And this is the download. Now, there's different versions of this Raspian. They call it Wheezy. One of them is the soft float, and one of them is not soft float. I'm going to tell you, unless you know you need it, do not get the soft float, because the soft float actually slows down the processing because it's doing more floating bit calculations. You more likely do not need it for what you're going to use it for. So you can go to torrent if you want, but I typically just go to direct download. And when you go to direct download, it's going to give you the choice of where you want to download it from, which mirror. So you pick the one that's closest to you, and it'll automatically give you one as well. So I'm going to go ahead and say, okay, I've already downloaded this, so it's going to be a duplicate for me. And in my case, it says it's going to take 7 minutes to download, which is probably about right. So look how big it is. It's 471 megabytes, so you can probably pretty much guess how long it's going to take for you to get that downloaded. So I'm right there at 4. I'm downloading right now. So here's the other thing you're going to need to get it installed. And where is the instructions? It's right here somewhere. Oh, I left the page. Okay. Okay, so we go back to the downloads right here, and you're going to see right up in here you have different things. So there's a couple ways you can do this in Unix, and I've done it both ways. Both ways work just fine. I am a command line person for Unix, so DD makes sense to me. However, if you come down and keep going here, if you're on Windows, you download this right here, W32 Disk Imager. And if you're on a Mac, what you do is just go over here to the beginner. So where it says Guide for Beginners, I'm a beginner, so let's click on the Guide for Beginners. And in here it gives you more detail. So here's the SD card setup, and we come on down, and here's the safest and laziest way. And then we come down to the easiest way, and you see for the Mac, you download this RPI SD card builder, which I have done. So I'll be able to show that to you. If you're on a PC, I don't have a PC handy to be able to do this with, but you basically download, after you download the image, you download this W32 Disk Imager, and it walks you through the whole process. So it's just as simple as it is on the Mac. So let me go over and show you on the Mac what you do. Let me actually get out of here so I can see my desktop. And here are my downloads. So here's the RPI SD card builder. Now I downloaded a while ago the image, so I already have it. So I'm just going to run this. And it's asking you what image you want. So I'm going to go to the downloads. And I know it's an IMG file. So I'm just going to look for IMG files that are in downloads. And right here, this I think is it. No, that's Screenly. I don't want Screenly. Oh, sorry, I typed the name wrong. It's .img. There we go. There's Raspian right there. Okay, so I'm going to double click on that image. And see, you see right here, my card is still plugged in. I'm going to continue. So it's already plugged in, and disk 1S2 is my disk. So I'm going to uncheck that one. And then it's going to tell me I need to use my password because this is a erase disk function. And you see it dismounted. So it says wait until it's unmounted. Click on continue. So now you'll see back here in the back that this SDI card builder is running, and it does take a while. So don't be like me and impatient and pull it out before it is done. So that is running in the back. So that basically sets up the card to boot using the Raspian or the Wheezy software or operating system. So after you start the operating system, it's going to ask you some questions. So you need to make sure it's plugged into some kind of monitor, because you have to walk through and expand. No, it kind of does this for you, walks through and recommends everything you got to do in the process. But what it asks you, do you want to expand on the disk, which you do, because if you don't, the whole card is not going to be used for the operating system, and it's going to run out of space real quickly. So it'll expand that. It's going to ask you want to change your password, default password, things like that. The default login is PI is the username, and the default password is Raspberry. So you put in Pi, enter, and then Raspberry to log in. You go in as a user, not as root. The root password is not set, so you can sudo to root to do anything you want. Easy. If you're a Unix person, it's going to make sense. If it's not, it's not going to make sense to you. It's one of the disadvantages of the Raspberry Pi. It does require a little bit of Unix knowledge, but it's not difficult. Don't be scared of the Unix operating system, because it's a very powerful operating system. In fact, if you more likely your phone runs on Unix, and if you're running on a Mac, you're running on Unix. You just don't know it, because Android and iOS, so Apple phones and anything Android, are all Unix based as well. Now, there's slightly different versions of Unix, but you're running on Unix, so you probably use it every day somewhere. You just don't realize that you use it. But you don't normally get into the nitty gritty of the command line. So if this is the first time for you, don't be scared. There's plenty of tutorials out there. But after you get it set up and you get around, you'll find it's actually pretty easy to get around. And if you ever use DOS, you'll be right at home in Unix getting around. It's not much more difficult than that. So while we're waiting for this, we're going to go back to the computer. I'm going to actually log into the Raspberry Pi that's sitting right here. Actually, before I do that, let me go show you how I have it set up. So what you have here is the Raspberry Pi. It has Ethernet plugged in right here. And you see down here the lights are flashing. There's power. These are link and activity lights. I do have this little USB plug-in for the keyboard, which I'm not really using now. I have the USB plugged in up here for power. And then I have I have ground, which is the green wire, coming from this pin right up here on the GPIO. And then the yellow is it's pin number 7, which is, you'll see in the code how I'm actually turning off and on pin number 7. It comes over here, and I have an LED with a resistor, so the LED doesn't blow. And the yellow wire goes to the LED, and the green wire goes to the bus, the right here. So that's pretty much how it's set up. A very simple setup, just 2 wires, just to power the LED. Okay, so now let's go back over to the computer. We can get over to the computer. There we go. Okay, so back over here on the computer, and I think I might already be logged into this. No, I'm not logged into it, but this is the command line on my Mac. So I'm going to SSH, and I'm going to log in as the user PI, and this is the IP address that the Raspberry Pi that's sitting here has. So I'm going to press enter, and it's going to look for password, and I haven't changed the default password, so it's Raspberry. All right, so now I'm logged into the Raspberry Pi, and if you're familiar with Unix, this is truly a fully functioning Unix box. So you see, those are all the processes that are currently running on this little tiny board. So all this is running. If you were on an Arduino, it wouldn't be doing more than one thing at a time. These are all running simultaneously on this one little card. And I'm going to show you how much disk space I have. So I basically have 15 gigabytes. Only 13 of it's available because I used 11% of it already. And that's just for the main operating system install. So it uses a little bit of space for that. So, but I still have 13 gigabytes left. That's plenty for most of the things you're going to do with small electronics like this. And if I do top, I'll show you my top processors. And as it's sitting here, you can see that it's sitting here at 98.7% idle, or is 99% idle. So this little thing is doing all this work. It's sitting here, hardly doing anything. It's just sitting here idle for the most part, which is absolutely amazing. In fact, the 1% that is being used is me running this program called top. Well, there's 0.3% of the system doing maintenance and stuff. So you'll see it bounce around, but basically it's sitting here. It's very powerful, and you got plenty of more growth space with this tiny little box. And if you need more space, you just put a bigger SD card in. You know, I only have 16 in here now, and that'll probably be fine for most things. All right, so I'm in my home directory. So let's go ahead and look at everything that's in my home directory, and you're going to see some Python stuff in here, and that's because I just earlier today installed Python on this, and you see flash.py. I'm going to do that one first, and let's look at it first. And it's very small. It basically imports a library called rpi.gpio, which is Raspberry Pi and GPIO, which is the general purpose input-output interface. That's what it is, general purpose input-output. Okay, so we just do a set mode on the GPIO, so set the board. We set up pin 7 to be an output pin. Sounds very familiar, doesn't it, to an Arduino? We import a time library, and that's because we're going to use the sleep function down here. And we do a while, and you see this is still a different structure. So while true, and there's a colon, and it continues. Okay, that's our SD card is done. So we set our output pin, we're going to say high, which turns it on, sleep 1 second, and we're going to set our output pin low, sleep 1 second, which will basically make the light blink. So let's run this real quick. Now, the GPIO, for some reason, which I haven't quite figured out why, it wants to run as root. So you're going to see me run this as root, and it's flash. All right, let me go over to the Arduino, and I'm not the Arduino, the Raspberry Pi. You can tell I've been on the Arduino for so many weeks. So you see the LED is flashing, just like our little program told it to do. And if I do Control-C to kill the program, it stops flashing. So we're back over here to this program now. The other one that I did is this read Ustream status right here. You'll see it's this one right here. And let's go look at it first. And it's actually not that long either. Read Ustream status. All right, so you see it importing a lot more libraries. And some of these I can probably get rid of now. I'm not sure. Let's go back and look. I don't think I really need the math one anymore, although I do need the URL lib. So basically, I'm including a bunch more libraries for Python to do some of these other functions. But it comes down, and you basically see there's the JSON. URL lib is how I'm getting the data from the internet. The time and date and time are for time and delays and stuff like that. And I don't remember what the OS and the SUTIL is, but I think it's shell utilities, which I don't think I'm using anymore. I could probably get rid of that stuff too. But anyways, we come down here and we do the same thing. We set our mode and we set our pin 7 as an output pin. And then we're defining our variable right here of Ustream URL. And this is the same Ustream URL that we used in episode 10. And what we're getting is we created a subroutine. So instead of function, it's called, you do a def. So I said this is a little bit different, but basically we're defining a subroutine called check Ustream. We're printing a blank line. And then we are basically opening up a file. And the file, rather than being a local file, is a web file. So we're doing this URL open to the URL that we passed in right here. And then data string is actually reading all the data. And then we decode that data string into JSON. And you see we're here going to print to the screen the status, the number of current viewers, and total views. And I'll tell you, for some reason, viewers now is not working correctly. And I'm not positive that total views is even working correctly. It seems right, because I think when I looked at it earlier, it was 173, which would have been since midnight. So it may be correct, but the viewers, I know wasn't correct, because I had at least 2 things up and it kept saying 0 all the time. So that could be something I'm doing wrong. I haven't figured that part of it out yet. That's not what the main purpose of this is anyways. Anyway, so then we close this file handle, and then we do a compare of the status, if it's equal to live. And if it's equal to live, we turn the light on, and if it's not, we turn the light off. Now you're going to notice here also the if then else. There is no then, but the if else is a little different. So it basically is broken down with colons at the end to group these together. And we keep on going down, and that's the end of that routine. Now here's how you end a routine in Python, is you basically have a blank line after it. So there is no brackets like you're used to in the Arduino. It's a little bit different kind of language. It just takes a little getting used to. And then right here, and I could have said while true, I could just done like I did the other one, or while 1's unequal to 2, because never they can be equal. I'm basically calling check Ustream, and then I'm sleeping for 60 seconds and doing it again. Now, the other difference in the language is in the Arduino, you have a setup and you have a loop, where we don't have that in, this is a top-down language. So that causes a couple of things. First of all, this right here where I'm calling the check Ustream has to be after I define check Ustream. If I put it above it, it would say it was undefined. So it would never run. So you have to put that at the very bottom. And it starts at the very top and it goes from top to bottom. It doesn't run the setup, and then it doesn't run the loop continuously. I have to basically make that loop myself. So if I didn't do this loop, it would go through one time and it would just quit. So again, it's a little bit of difference in the language itself. So let's go ahead and we're going to run this. So I'm going to get out of this. And again, because I'm using the GPIO, I have to run this as root. All right, so I'm going to run this. And it happens so fast you wouldn't be able to tell. But if you look at this, the light is green. And that light will stay green for as long as the stream is up. But let me go back to the computer because it's going to keep outputting data every 60 seconds. So we're going to go back over to that. And you see it says live, so I got that back. We got the current number of viewers, which doesn't make sense to me because because I'm looking at the Ustream stream and I see we got 6 people in there right now. So it's not necessarily making sense to me why that's coming back at 0, and I haven't had a chance to investigate that yet. So we'll table that one. The 175 could be correct. Those are the number of viewers on Ustream since midnight, and it's very possible that is correct. I have not confirmed that, and I don't have an easy way to confirm that. But as we sit here and we wait, you're going to see after 60 seconds that it's going to run this yet again. And I have no way of taking the stream down, unfortunately, with the new software without taking all the streams down. Okay, there we go, live, 0 and 175. Let's try something here. While we're waiting, I'm going to wait one more minute here. So in the end, what I would do, you see I'm running this from the command line, but in the end, what I would do is I actually would set it up as one of those processes that you saw running automatically. It's very easy to do that. So as soon as the device boots up, it would come up and start polling right away. And the other nice thing about this being multi-threaded is I can actually write another program for a different stream, like maybe for Justin TV or something like that, and have them running at the same time, and maybe have Justin using, instead of pin number 7, pin number 8 on the GPIO. So I can actually control, demonstrate more than one thing very easily with, there we go again, another minute passed, live. Sorry about that. I was trying to generate another view, so 175 would go to 176. So we'll see what happens here. Still trying to do that. It's still loading. All right, it's loaded. So let's see if this number goes up now. That's a good test. So anyways, this device can do more than one thing. Now, one of the things that some things that I want to do with it, in addition to just checking the stream, is if I can get this data to come back reliably, I've already installed a program called MRTG. It stands for Multi-Router Traffic Grapher, and that's what ISPs use to check for bandwidth on ports and stuff like that. That's weird. Now it shows one viewer, but my other thing says 7. That's weird. So anyways, the part of the idea is if I can get this data, I can record it, and it'll actually graph out the usage of the stream. So in addition to just being my on-air light, it'll be capturing data as far as the performance of my channels at the same time, or all of my streams. So I can tell, I broadcast this 4 different streams right now, and if I can get all 4 of them to do this kind of data, I can use it to graph, just basically go to the IP address of this device. So my little light will be doing more than just a light. It'll be doing data logging as well for me, and that's part of what I want to do with. That's why I wanted to expand it beyond just. That's one of the reasons I wanted to expand it beyond to using the Arduino, because and also the ability to plug in a really inexpensive $5 wireless USB and get it to work is another reason. So, all right, let me go ahead and do this. Let me get out of that and see what it does. And as you can see, if you go to it, we still have a green light because the stream is still up. Now what I can do is I can actually unplug Ethernet, and you'll see the stream, it looks like it goes down, but it also has other issues. Doesn't do it more than once until it crashes, which is a bug or a debugging thing not to fix. So that's still left to be done. And so while we're waiting for this next time to come through, I'm trying to see what it does. Look back over here. The other thing I'm going to for is when you're looking at this new studio that we're in now, we have TVs behind us, and what we want to put on those TVs is the name of the show or other information, kind of like digital signage. So there's actually a program that there's a bunch of programs that do digital signage, but there's one company that does digital signage that has actually taken and created a Raspberry Pi image of their digital signage. So I have that, and I'm experimenting with it now to see if I like it or not. But the idea would be is each of the screens behind it would run off a Raspberry Pi, and it would be able to be remotely controlled. So every time a different show is on, we can change what's on the screens, all via remote using an inexpensive Raspberry Pi. Now, let me tell you another way that I use a Raspberry Pi, and that is for remote control. I do some remote support for some people, and it's easier to put one of these, and cheaper, put one of these in there on a dedicated IP address, and I can remote into it just like I just did, and I can actually set up an SSH tunnel through it as well. But I can get into their system, get into their network through the outside to a secure tunnel, and then get into the network and get on the routers or whatever else I need to do maintenance for them. And it's a nice way of, there you see, the one went down to 0. And I got out of my thing that I was doing with Ustream, but the count never went up, and it's still saying 6 on my Ustream computer, but the stream still telling me it's 0 now. So we haven't quite figured that out yet. We'll figure that out. But anyways, that's what it's doing. So it's a bunch of uses for a Raspberry Pi, and they're very expensive. They're like $25 now for a Raspberry Pi. And it's very quick. It takes you like 10 minutes to get one up and running, and it's the great way of experimenting with multi-process computers. If you're not familiar with Unix, it's also a great way to learn Unix, and actually that's what it was designed for. It was designed to teach kids how to program. So that's what the person who created it, that's what they wanted to do with it. So the thing is, it's so powerful, it's useful for so many other things, and the whole maker community has jumped on it, and he sold many more of these than he originally had planned on selling. And there's actually a good site. It's called Element 14. There's some good documentation and different ways people have used the Raspberry Pi. It's actually very, very amazing. And I plan to do a lot more projects in the future. Maybe an internet radio with it. There's a bunch more things you can do with the Raspberry Pi. It's amazing. If you just look for Raspberry Pi projects in Google, you'll find tons and tons of them. And it's about almost as many for that Raspberry Pi as there is now for the Arduino. And in some ways, I think the Raspberry Pi is a little bit more flexible. And if you already have a little bit of Unix knowledge, which a lot of people do now, you can jump right in there and work right on it without any retraining at all. So it's a great little board. So before we go any further, I do want to talk about our sponsor for this show. Our sponsor is Ting. Ting is a great new mobile phone company. It's one of those things where it's almost amazing, why has somebody not thought of this thing before? And now that Ting's come out with it, I'm now hearing other phone companies that are talking about coming out with this. I heard T-Mobile this week was going to do something very similar to Ting, where they're going to do no contracts and bring your own device type stuff. So let's go look at why you'd want to go to Ting. I mean, Ting it's actually very amazing. And first of all, they're from the same company has 2 cows. If you ever use 2 cows, or ever to call them, or you ever have a domain with Hover, if you ever have to call for support, you get somebody on the first ring. It never goes into one of those machines where you got to press numbers or put you on hold. Between 8 a.m. and 8 p.m., they will never put you on hold. Everybody is empowered to take care of you. They don't got to go to their manager. They don't got to escalate you. They basically can take care of you. Now, their number one reason is the rates. I'm going to go through the rates here in a little bit. It's actually amazing that somebody can get away with this. In fact, they run on the Sprint network, and they blow Sprint out of the water with their pricing. It's amazing. So there's no overage penalty. So if you say I want 500 minutes a month, and you go up to 600 minutes, you don't get a penalty for going over. All they do is they say, okay, we'll bump you to the next level for this month, and the next month you go back down to where you were. So there is no such thing as an overage penalty. There's no fines for using your phone. They do the exact opposite on months you don't use it. Say you wanted 500 minutes and you didn't even use 100. So you want to go down to the 100-minute plan, they'll drop you right down and credit you for what you actually used. You can put multiple devices on one plan, which means your minutes are shared, your text are shared, and your data is shared. And we're going to put together a plan for a 4-member family when we get over to the rates, and you'll see the difference in pricing. It's amazing. It's great for small businesses. Again, you combine all your minutes, so you have a big pool of minutes that way. It's a great way of doing that. Again, there's no fees or limits on any kind of usage. It's unlimited. It's as simple as paying for what you use. They have all the free features, including things that aren't free with most carriers. Hotspotting or tethering is typically not free, and it's included with Ting. There's no contracts. If you get Ting and in 2 months you need to drop a phone, or you need to add a phone or whatever, it's all no penalty. I mean, there's no penalty for it. It's great. Think about these. They call them strategically used devices, but I look at this from the point of view of like, say maybe your mother or your grandmother. They not used to phones. They didn't grow up with cell phones, but they're getting up there in their age, and you just want to make sure they have a way to get in contact with somebody if something would happen. Well, you pay for a phone, and it goes into your plan of minutes. So you pay $6 a month for the phone. You just tell them to stick it in your glove box. And if you break down, here's how you use it. And for that $6 a month, it's like all the insurance that you need to keep your loved ones safe. Or it could be your son or daughter's going to college. You know, you maybe have their own cell phone, but you want to make sure they got one in the car. So you stick one in the glove box, that type of thing. And you can think of many different ways you can use these devices. And for $6 a month, you can't beat the price of the device. You can they have a bunch of devices. We'll go and look at the devices, but they are all smartphones you can think of. You know, so very Android centered devices. They have feature phones, you name it. Plus, they can also any phone that works with Sprint, you can just bring over to Ting. So you can bring your own device over to Ting as well. I mentioned before about their support. They call it geek-powered support, but basically they are empowered to help you on the line. They're trained well. They know their phones inside and out. They know their service inside and out. And if you get a problem, they don't have to go to the supervisor to get things fixed. They can just do it themselves. And I mentioned before, between 8 and 8, there is no hold. So you basically whenever you put on hold. They speak Android, very much so. We'll go to the devices here shortly, and you'll see their Android devices. Their bills are very easy to read. Graphic, nice graphs to show you how you're being used, things like that. Things you don't get with your current cell phone company. And bills that actually are easy to read and make sense. And like I said, there is no penalty for canceling. So let's go up here and look at the plan. This is the most amazing part of this. So let's say you're a family of 4. So we're going to come down and we're going to say we have 4 phones. So it's $6 a month per phone. So there's $24. And we'll say you do 1,000 texts a month, 500 minutes a month, and let's say a gigabyte of data a month. That would cost you for 4 phones, a family of 4, $62 a month. Let's say your family is a little bit more on the texting craze. A couple of your kids go a little nuts, and you use a little bit more of the minutes for calling back and forth to work. So here we go with 1,000 minutes a month, 2,000 text messages, and a gigabyte. That's $74 a month for a family of 4. That's just nuts. Maybe you do a little bit more data than some people. So you go over here. Here's 2 gigabytes. You're still only at $92 a month for a family of 4. That's just nuts. Like, it's unbelievable. And it's very easy to get started. You come right over here and just click on the Get Started. And you can change these plans at any time without any penalties. You can go up or you can go down. And if one month you go a little over, say, 1,500 minutes because you've been on the phone with work for a crisis, you pay a little bit more for that month. But next month you go back to the 1,000 minutes at $18. And they're not going to charge you a penalty. They're just going to charge you the difference of $17. That's all. So let's look at the devices. Like I said before, almost every device is a smartphone, except for just a few feature phones at the bottom. So here's you see the LG, the Samsung S3 is here. You see the Galaxy Nexus. So all the good smartphones are right here. And you can go down. Here's some feature phones. They're not overly feature rich, but a lot of people don't like the smartphones. So this fits in just fine. And they also have data. So you see Home Connect. So you want to bring Sprint into your home. You don't want to go get a landline. There you go. There's your Home Connect. You have an area. You live in an area that's not covered very well by Sprint. Here is the Sprint Airwave. It plugs into your internet and it gives you internet access right there, or phone access right there in your home where you don't normally have coverage. They even have used devices here. You can get used devices at great prices. I mean, look at the prices. And the thing is, the phone is yours. There's no contract. So if you decide to leave, the phone is yours. It goes with you. You can use it on any other carrier that you want. That's the nice thing about Ting, is there's no contracts. All right, and you can see here you can bring your own, and you can also sell. So one more thing I want to go look at, and that is the coverage. And this is the amazing part. because they're using the Sprint network, they are pretty much everywhere. Look at this. This is all their voice coverage as it is right now. That's just amazing. And they have 3G and 4G coverage throughout a lot of the country as well. 3G is almost everywhere. 4G is being rolled out to lots of places already. Okay, so the other thing you can do before I let you go from this is the savings calculator. You want to see how much you're going to save? This is where you go and you do it. You basically come in and fill out some information, and it will show you how much you're going to save on a monthly basis. So that is Ting, and they are a sponsor of Let's Make It, and we love having them. They're a great company to work with, and I use their other companies as well, like Hover, for all my domains, and they're just awesome. Their whole philosophy is the support of the customer. Okay, that was our sponsor for this show, and next week I pretty much am trying to promise you that we will be doing shift registers. So Bob Powell, one of our viewers, has sent me some sample code he has as well, and I'm going to try to include all that, and I'm going to see if maybe Bob will want to try to join me for the live show. I don't know if he will or he won't, but he has definitely sent me some samples of some stuff he's done, and I'm working on some things as well, and we'll try to make it a good show. It's so much stuff around shift registers and things you can do with them that we may actually end up doing more than one show around them, because you can control relays, you can control the LEDs, which I'm going to show you some LEDs. Using shift registers, that's the easiest way to show you kind of how it works. So there's a bunch of things you can do with shift registers. There's almost unlimited number of things you can use them for, and it all stems around limiting down the number of pins that are actually used out of your CPU. So whether it be, you can do the same thing with the Raspberry Pi as you can with the Arduino. It doesn't matter. So it all works the same. I do want to remind you that if you are not watching us live, we do record the show live every Tuesday night at 7 p.m. And we'd love to have you here in the chat room with us and chat with us. And we do watch the chat room while we're in here and try to interact as much as we can throughout the show, and answer questions as much as we can as well throughout the show. If you are not watching us live, you mean you're probably watching us on one of either the download mediums or something like Stitcher or something like that. If you're watching us on iTunes, I would definitely appreciate if you go out and give us a rating on iTunes, because rating us on iTunes helps us get found and helps us grow the show a little bit more. If you're watching us on YouTube, a couple things you can do to help us out there. First of all, you can click the like down below, and you also share it with your friends. That's definitely helpful. Comments also good as well. And there's a button on this to subscribe that just makes sure you know when we put out a new show. So that's another thing that we would love for you to do, so that you know when we have something new for you to go watch. If you have some friends that are into this kind of stuff, please spread it around. We love to grow this community. It is growing, and it's growing very quickly. We get a lot more emails now than we used to, and that's a good sign, because it means people are watching the show, and we love that, because we love getting the feedback from you. If you've created something and you would like to share it with us, create a little video, stick it up on YouTube or Vimeo or somewhere like that, and send us a link. We don't open attachments, so it's not good to open attachments for people you don't know. So if you send us a link, we'll go to YouTube or whatever and we'll watch it. And it also keeps our mailbox size down just a little bit, so we're not running out of mailbox space. But we definitely look forward to hearing from our viewers. And again, if you can come and watch us live at 7 o'clock on Tuesdays, Tuesday evenings, and it's 7 p.m. Eastern time. Now it's Eastern Daylight Time, because we are now in Daylight Savings Time. We definitely would love to have you there as well. If you are getting us not automatically downloading, best thing to do is go somewhere like iTunes or your favorite podcasting directory. And we're also now on thetechpodcast.com, and we have a Roku app as well. And we have in the App Store, waiting for approval, our iPad and iPhone apps. So we have a bunch of different ways you can get us, and that goes for all of our shows. The Tech Zen, we're currently doing 6 live shows a week, and we're getting ready to go up to 8 live shows a week. So we have 2 more shows getting ready to come online. So if you want to check out our other shows, you can go to tech-zen.tv and check out what other shows we have. And while you're there, you can also go find the show notes for this show. And I will put out online for this show all the links to all the downloads for Raspberry Pi and the instructions. I'll put links out there for that, and I'll put the code for both the Python scripts that we just showed you out there as well. So if you have questions about this or you want the code that we looked at, that is the best place to go, is tech-zen.tv, and you will find our show notes out there for this show and all other episodes of this show. If this is the first time you've seen this show and you liked it, you probably would enjoy the other episodes as well. So again, techzen.tv, it'll go to the Let's Make It show and go through the other episodes. If you would like to leave us a voicemail, you can do that as well. There's a phone number on the show page at techzen.tv. And basically what it is, it's a Google Voice number. So we do not answer that. It is a voicemail only, but you can leave us a message, and you may just hear your message on the air in a future episode. All right, that is it for Let's Make It this week. We will see you next week.